Hey everyone, I'm Muddassar Sharif, and I am an AI engineer who has been building and deploying AI systems in production for a while now. I feel like right now, everyone is rushing towards building some kind of AI system in production right now. And then that is where I've seen different stakeholders ask the question, how do we make sure that our AI models are working as we want in production? How do we make sure that we get the maximum ROI? Because that only happens if your models or your systems work as you want, right? And not the other way around. And that is why this is really important talk. I believe that everyone, for example, different stakeholders can be executives who want to oversee the entire AI stuff happening in their company, and also at the same time, engineering managers who are overseeing different LLM projects, how can they think about how to measure the models and systems, I would say, in production. And that is why, for example, in this shorts talk, I will be covering all the important, I would say, concepts that the entire industry has been using to monitor systems in production. And then from these concepts, we can think about, for example, okay, so how do we measure LLMs in production as well, right? And then after we cover different tools, different concepts, towards the end, we'll sum things up as well. So the question is, what is model monitoring on a really high level? There are two main things, there are two main goals. The AI system, towards the start, when you are building a use case, you define how you want the entire AI system to behave. And you define some key KPIs that you want to track. And then the goal is to simply see, is the model able to meet or exceed those KPIs in productions or not, right? One example can be, let's say a bank, every time you go and swipe your credit card, there's a model that the bank used behind the hood to simply classify if the card was used by someone who is not you, right? So they have to, for them, they are monitoring how well the system is able to tag fraudulent transactions versus the non-fraudulent one. That's one example. So their KPI is the percentage of fraudulent transactions they were unable to tag in production, right? So for LLM, for example, let's say you have an LLM system in place, which you are right now using to automate questioning answering. For example, there is customer support use case, or you have a vendor who's providing you with an AI tool that is able to automate the entire customer support tickets. How do we make sure, in that system, is the model able to provide accurate information, or LLM is giving the accurate information? That is a really important KPI that you want to track. So very important, I would say, on a really high level in summary, you define what you want to track, number one, and then based on that, you define all the other I would say, KPIs you want to track. So before I move forward, it's really important to understand that model tracking, if you look at the last 10 years of the history of what's been happening in the industry, there are two main things that everyone is tracking and it's worth tracking. Number one is, for example, what goes inside the model, and that is called data. And what comes out of the model, that is called some prediction or some token, if you think about the LLM domain. So before LLMs, when we think about in machine learning use cases, we track all the inputs, it's called data, and then we track the output, it's called concept or prediction drift. The same also is happening right now in the LLM space as well. So what do we do, for example? Okay, so once we define, and then we'll talk about more in detail, how do we define different KPIs? What's the end goal here? The end goal here is that some system has to be there to track the model and then let us know when there is something abnormal, right? So we can go back and fix it, right? So, and then in the ideal case scenario, you want to have a system in place that can, number one, track and at the same time trigger some pipeline which can go and fix the entire model or retrain it, or simply, if you are in the LLM domain, improve the prompt. So the goal is to track and then in the end, improve systems in production and make sure the output is how we want the output to be. And then there are different tools out there to do that as well. So if you think about the LLM domain right now, there is Athena that's doing a really good job. And then at the same time, there is Langsmith that is also doing a really good job right now to provide you with the entire monitoring and how things are going in production. Let me quickly show you the entire Athena AI. Moving back towards what do we want to track? So there are two things we want to track always. You want to track what data that goes inside the model and how is that data changing over time. Let's suppose like you have an LLM system in place for customer support, and then you have built that system to handle tickets regarding refund and change in delivery address, for example, right? That system is employed in an e-commerce domain, and then you only track these two things. That's the input: refund requests and change in the address requests. So let's say like in the production that, for example, the tickets that are coming up are not about refund or are not about the change in the address. The tickets that are coming up are complaints about the performance or the quality of a product. Means what? There's a drift. Means what? The input that the system was built to handle. You have a system in place to handle refunds, and then you handle, I would say, change in the address. Now you have some different kind of inputs coming up, right? So in that case, we call this drift, and drift on the data level. In that case, normally, for example, like since you never build a system in place to handle those tickets regarding faulty product, your system is going to perform as expected, pretty much, right? That is called a drift on the data level. The other example that I can think of right now is a bank. Let's say a bank has a system in place, they have a model they have trained on the customer data to tag transactions as fraudulent or not. And for example, and let's say that bank is expanding in a new country, right? Of course, when they expand in a new country and they open up their shops there, and then they are offering credit card to different clients in that country, of course, the data that will be coming into the AI model will be different, right? Because different in the sense of location and other attributes, right? For sure, right? So that is where we call this drift. The inputs that we are sending in the model has changed over time. Means what? The system that you had built before is no longer going to work in this case. So you have to go back and fix it, right? Or you have to either find a way to handle these new requests, or you have to build or retrain the entire AI system to make sure it handles all the scenarios whenever there's a drift in the data level. Normally, for example, like how do we do that? We track distribution. So I do have a few right now, really good examples to show as well on how do we like easily measure drift. It's normally distribution, for example, right? Let's say the distribution on the location level was only the US, but now that a new bank has opened up their shops in Europe, right? So normally you have a different distribution coming up. Simple as that. So your input, again, the input, it was, and sometimes blue, but over time it's mainly, I would say, blue and less red. Or, for example, before there was more mainly online transactions, and now there are more offline transactions. I don't know. Maybe the COVID is gone now, for example. And that is an example of a drift. The data that's coming in has changed over time because the world you operate in has also changed over time as well. And then, for example, if I think about the LLM domain right now, we talked about, for example, that the tickets that are coming in, there are different tickets now. Something has happened in the system before. So moving on, for example, the other really important concept that we have to track is the drift in the output. And that is mainly called model drift. Why is that happening? It's quite possible, for example, and the output drift happens for two reasons. Number one is, for example, like over time, the input is different. For example, it's quite possible the output is going to be different for sure, right? There's difference in the output driven by the input, number one. And number two is the concept drift. That happens because the model was built to learn patterns in the data, and that data represents a world right now in 2025. It's quite possible that in 2-3 years, how people buy stuff can change, right? Over time, it's quite possible that the relationship between different variables in play are different now, and that is where the models is not going to give you the right output or prediction in that case. To think about a few examples right now towards concept drift, let me open up this link really quick. Yep, I think that's a really important example over here as well. So sales, like they were mainly online sales, and now there's offline sales. And it's quite possible that, one example can be, for example, if you have a new store and then you see that your sales is more seasonal, right? But as the store and as your business grows over time, you have a strong brand. It's quite possible that you are collaborating with different influencers, right? And then for example, it's quite possible that at that time, like your sales are not entirely driven by seasonality. It's also driven by different events happening or different campaigns you run. So your sales, your prediction is no longer, I would say, dependent on IT or something else. It's a different business or different concepts in play. That's the other example of, for example, concept drift, that the model was, once again, it's really short. The model was trained to learn a phenomena, and that phenomena has changed because the world has changed. And that is where you can see, expect to see model going wrong or not giving you the right output. So like simply, for example, if we are tracking drift on two levels, there's input and the output, or data and the model, then the alerts are also going to be on these two levels, right? For example, so sometimes, for example, it's quite possible that we like, hey, it's okay, for example, if there's a drift in the input, but as long as there's no drift in the output, we are fine, right? And that depends on the use case. It's quite possible, for example, that LLMs were not given instructions on how to handle requests that are coming in about some faulty products, right? But that LLM for customer support is smart enough to handle these new requests because these models are really good at understanding the language. In that case, like you might say, hey, the input difference is not really important. The output difference is really important. For example, if you see models giving the output that is not backed by citations or giving the output that contradicts what we have in data, or there is some hallucination, for example, different metrics we track in the output. That is the most important thing to track. And then, for example, like in the other case scenario, for example, in finance or in healthcare, they might want to, for example, track both the inputs and both the output. Means they want to track all the drift in every variable they input in the model, and they also want to track the drift in all the output or as well, right? And then, for example, like how much drift is, I would say, is something that you can accept, but it also depends on the use case. For example, if there's a model that I've trained to predict sales, right? And then I see that there's a drift of around 10%. It's quite possible that my demand forecasting or sales forecasting model, I already have that like error threshold in place, or I've already stocked my inventory 10% more than the prediction. So that small amount of drift won't be super important. But on the other hand, for example, a bank or for a health case, use case, even a 1% drift for them would be super important, right? So that threshold is something, for example, that has to be defined by the company. So if you just think about the LLM cases right now, because that is where majority of the work is happening right now as well. So on the input side, the most important thing, for example, for them is the number of input tokens. It's really important. On the input level, for example, I've seen companies also track as well the sentiment as well. For example, let's suppose if sentiment of the tickets you are receiving in your customer support LLM agent has changed over time a lot, then it's quite possible that there's something wrong happening, or there's some change in the overall system or overall, I would say, world. And then it's worth going back to think if we have to go and change our prompt or change something else. And then like on the output level, for example, there is hallucination that you want to track as well. There is number of output tokens. For example, let's say like before you saw that the model is always giving you like 500 tokens on average in every output, but now all of a sudden the models are giving you 1,000 tokens, for example. Like that's something you want to go and understand, or like why is the output number of tokens different? It's quite possible that there's a drift on the concept level, right? For example, the phenomena that you want to track and you want your models to handle that phenomena it's very different now, because maybe like the store has grown, the tickets that are coming in are not only around refunds, there are more tickets about some other queries coming in. And then the two very important tools that I've seen right now in action, I use like Athena in my companies, just because like they have a really easy to build, I would say, system in place. But at the same time, like I've also seen Langsmith people being used a lot. Both of these tools have one really important thing. They track every inference or every prediction. So you see, for example, okay, so what's happening? And then, for example, you also have the ability to simply track the change in tokens, and then you can also build your own tracking evaluations or KPIs to track, for example, on hallucinations. And then you also have ability to track different various aspects, both on the inputs and both on the outputs level. Yep, I think we covered that as well. So, and then, for example, like different tools, if you think about where, if you have a different machine learning system in place, then I've seen evidently AI being used a lot. It's an open source tool used by a lot of people in the industry. And then they have both different KPIs being built on the input and output level. And then you have the ability to simply think about which KPIs or which metrics you want to monitor as well. I think we covered different examples before. So towards the end, on a really high level, for example, we never went into detail on different on maths behind different concepts. For example, like how do we measure drift? Okay, so if drift is on the distribution level, for example, what are different formulas or concepts that are in place to measure the difference in distribution? That's a different topic, right? So, but like in this short, I would say presentation, my goal was to simply explain that monitoring is happening or has been happening on two different levels. There's either input that goes in the model, and then there's the output. The input is called, and then the change in the input is called data drift, and then the change in the output is called model drift. And then within these two buckets, there are different KPIs you can think about. If you have a traditional machine learning system in place, then it's simply different distribution. For example, it's quite possible that you have one input variable location. Before, location was only different cities in the US, but now you have location as different cities in the US plus in Europe plus in Asia. Means what? The input has changed. If the input that goes in the model is different, the output will be different, for example. Number two, the output, for example, before model was giving a prediction always more than 50, but now you see model giving prediction between the range of 30 and 60. There's a difference in the prediction or on the output of the model, and that means there's a drift in the output. So that means something. And these are two different buckets that you always have to track. And then how much drift can you afford? It all depends on the use case in healthcare or in finance, where you have regulations in place. And how much drift can you afford depends on the regulations and depends on the loss the company can incur because of that drift. In some use cases, like you always have an error built into prediction. For example, retail, they always know, okay, so if they are doing demand forecasting, they always like overstock, because like it's fine to have an extra stock versus having less stock, because there's more loss to the company if customer walks in the store and goes out without buying stuff. So they always overstock. So for them, they can afford to have a big drift. If there's a big surge or big drop in the demand, they're always prepared, right? But on the other hand, for example, like for them, if their prediction is like they will sell 1 million SKUs, they won't be stocking 5 million, right? They will always be stocking 1.2 million, right? So for them, they need accurate prediction, but in the end, they are fine if their models have a really big drift in the output because of different reasons in place. So this is on a really high level. For example, how do we monitor our AI systems in production, and how do we make sure that our models behave as we want and we get the maximum ROI because as a result. Signing off now.